All right, good afternoon all. So my name is Victoria and I am the Graduate Writing and Research Assistant at the Oakland University Writing Center. I know some of you that are joining us today, so I am glad to see your names. If not your faces here today, you're welcome to turn your camera on. I'm just letting you know that I am recording this today so that we can make this available to you all and to anybody else that was unable to join us. As part of my job at the Writing Center, I conduct research at the Writing Center and then in my own department in psychology. So I'm a bit comfortable with statistics and SPSS, and I thought I would give you guys more of a ton of information today and then allow you to ask questions specifically related to what you're working on, or maybe a little bit more about SPSS. And then I also created a very long, 70-page manual for SPSS for you guys. And I sent that in the email. So if you look at that and have any questions, we can absolutely go through any of that today. Feel free to stop me at any time. I have the chat up in case I don't look at it. Lily is here and we'll be monitoring the chat. Also, feel free to put your hand up virtually and I will get started. So we're going to begin with the introduction and the important terms, very generally how we should be discussing statistics. Then we're going to discuss the difference between descriptive and inferential statistics. Then we're going to move to SPSS and the manual. We're going to work on improving our own research, so yours and mine. And then we're going to also, I'm going to open it up at the end for questions. Lily, if you would just forward Katie the information from today, please. So statistics, it is something that is probably the most overwhelming for individuals who are beginning their master's or PhD programs. It's something you may or may not have learned in undergrad, depending on your degree, but it definitely can be a lot more daunting and overwhelming than the writing process, just because there is so much information out there. And so today I want to work on very generally what you guys will need to know 100% for your dissertations and your thesis. So I don't want to give you guys all of this information and you not be able to use any of it. So when we begin, we either look at qualitative or quantitative statistics. And most of you, I think today, will be working with quantitative research. So that is our numbers, our graphs. It generalizes facts about a topic. So if you're conducting surveys or doing observations or experiments, that's what you'll be working with. And those of us, maybe Lily and Katie, work also in qualitative research, and they work with concepts, thoughts, individuals' experiences. So that's when you're working on interviews. Maybe you're working with children and you're getting more qualitative data than quantitative. And then mixed methods research is when you combine these two and you do a study that is both of them. So basic terms, statistics, it is mathematical procedures, not just numbers, but procedures for summarizing and interpreting observation. So it should feel better at the end if you understand a little bit more, then you can find that order in the chaos. So you gather a ton of information, a ton of numbers, and you feel very overwhelmed that your Excel sheet is now, 20 columns by 500 rows. We need to find order in that chaos. And so data is each individual point and each individual column and each individual row. Those are those numbers that we want to understand and summarize. And I just want to make a note here that data is plural and datum, D-A-T-U-M, is the singular version. So that's really important when you're writing, that data is always plural. So something that is incredibly important before we begin SPSS is the scales of measurement. So measurement is how we assign our numbers, our rows, our cases to represent that quantity or attribute possessed in each case. So it matters because statistics deal with numbers, but we need to know what the numbers represent. And I'll get into specifically what that looks like, but one could represent an individual participating in something one time. One could represent whether you rank someone as male or female, or one could represent an individual who came in first place. So it's really important that we discuss those. And then the data informs this data informs the statistics, which informs our knowledge. Okay, so our first scale of measurement, and this is covered actually in our SPSS guide too, if you do want to look at it on page 4. Nominal is like characteristics. So what I was just saying about gender or sex, species, so I work with animals, so species, it's when you give an individual a 0, a 1, or a 2, and those don't mean anything other than everybody who identifies as male is a 0, everyone who identifies as female is 1, everyone who identifies as non-binary 3, and so on. So it gives them an identity that it otherwise is not associated with that number. And then ordinal, so that is order, exactly like it sounds. So this is very important that you work away from nominal and you start working towards ordinal, because ordinal actually gives a characteristic to that number. Someone coming in first place is very different coming in second place. Again, an individual, if you're studying college students, an individual who is a freshman or ranked as a 1 is very different from an individual who is a sophomore at a 2, a junior at a 3, a senior at a 4, a graduate or master's 5, and so on. Those are going to be very different to know those identities. So keep that in mind. Moving up that ladder, interval is, again, the number is really important, but equal score differences do reflect equal differences. So a Fahrenheit scale. So 100 degrees is different from 99 degrees, is different from 98 degrees by a measurable 1 degree. So that's really important. So an IQ of 180 is very different from an IQ of 150 by 30 degrees. And you'll see what I mean in the next one. So in a ratio is a bit different because it is the same as interval, but has this non-arbitrary 0 point. So 0 doesn't have an attribute. You aren't 0 in age. There's no 0 volume. You're not going to use the 0. And a 50-year-old is greater than a 40-year-old by 10 years, but that might not mean anything in your data. And then the same thing with the Kelvin and volume as well. 10 ounces is definitely half of 20 ounces, but you're never going to measure 0 ounces of volume. Okay, so why are those measurement scales important? The measurement scales are important because all statistical methods, anything that you want to use, assumes that outcome measures are on a certain scale. So you need to assign all of your individual variables a scale before you put them in SPSS, or you need to put them in SPSS and then assign it. A little cheat here is a lot of outcome variables are measured on at least an interval scale. So that means at least an interval. Nominal is our first rank on the ladder, then ordinal, then interval, then ratio. So a lot of those tests you cannot use if you're looking at sex, which is nominal. You have to use it for something like GPA or age that are measurable differences. So interval and ratio. So if you're looking at just age, then you can't look at those tests. So then you can look at non-parametric, and those can be used for data on an ordinal or nominal. Non-parametric is a little bit different. I would highly recommend talking to your advisor if you decide to use non-parametric. I don't think any of you will have to use it, but it is something to consider. Okay, moving forward, some of our basic terms. So we have descriptive statistics and inferential statistics. So this is kind of where I want you to split your brain and tackle what you can here. So descriptive is that used to summarize or describe a set of observations. And again, I'll give you a little bit of assistance on how we should look at that. And then the inferential is how we can interpret or draw inferences about a set of observations. You all will have to do both, but tackle one at a time. So descriptive is going to tell us everything we want to know and need to report about our data. And inferential is a little bit more cognitive in how you want to look at your data and your theories and your hypotheses. So when you're reporting descriptive statistics, there are 4 different things that sometimes people look for. And that is central tendency, or middle or most typical value. Measures include mean, median, and mode. And here you are going to almost always, 99.9% of the time, need the mean. And I can show you how we do that today. And then we have the dispersion or variability. So that is the standard deviation. So the standard deviation is how far that middle value is, or how far all the other values are from the middle value, excuse me. So if I say my age is 27 and one of you is 30, the standard deviation is 3 then, because you are 3 years older than me, or so on. If someone is only 20 here today, then the standard deviation is 7 and 3 averaged together if there were only 3 of us. So it is the difference between all of that, or the average of that. That is also something you are 90% of the time going to have to report. Then the skewness is the distribution. So let's say you are measuring only college students, or you are measuring an entire population of students, but you're going to have some older students in there that might be older than 30, but you have 400 students that are in their 20s, their early 20s. You are going to be skewed to a very young age. So you might decide that anybody over 25, you're going to cut out of your data because it might just throw off or be an outlier. And then the kurtosis is the distribution of the tails relative to the center. So it's kind of like the skewness, but I won't emphasize it today because I don't want to confuse you all, but it is something to keep in mind. But the median and the standard deviation, 99.9% of the time. And then the range is something instead of the standard deviation that some individuals like to report. It's very similar, but it might give you a better picture of your range, like your age range, rather than, so that would be that 20 age to 30 age range instead of that standard deviation of 3 and 7. Something for inferential statistics. So inferential is going to, again, help us infer what the data means. So you are all going to test a sample. A sample is a subgroup of the population. So the population, if you were to measure them, if you were to be that lucky, and you would have to look at the entire population of a group. So if you are interested in understanding all young men on the autism spectrum, then your population would have to be everyone in the entire world. That's a population that is on the autism spectrum. Now your sample would be, let's say, those within Michigan, within our county, who go to a certain school. That's your sample. So it's important to not be super closed off here. And you can make generalizations based on the population, but it's always important to remember that you only have a sample. So again, population is all women, whereas the sample is women in a particular college course at a particular school. And so the population samples, then descriptive statistics will look different. Their means are going to look different between all women, and their ranges are going to look different between all women and women in a particular course. So again, you report a sample. You don't ever talk about a population when you're writing, you only discuss a sample. Okay, so population, all of the individuals of interest. You are interested in all of the young men who have autism. So you then decide what's achievable for you. So if you think you can achieve all individuals within Michigan, then that's what you try to select. So maybe it's all of the individuals within Michigan who have autism, but maybe a ton of them weren't able to fill out the survey, or you weren't able to do research, so it narrowed it down to your sample. And then your results from that sample, if you conduct it well, are then generalized to the population. So if you learn that generally males are diagnosed at a certain age more often, then you can then generalize and say, in Michigan, this happened. It might happen for the entire population. So sampling, and this is also found on page 4 of the SPSS manual. So sampling is the process of selecting that sample. So it's saying, I cannot tackle all individuals within the entire world. Where is the best for me to tackle for myself? What's like the most feasible? And also, what is the best to better understand the population? Because that's what we're trying to do. We're trying to generate knowledge to better understand the population. So you can do that randomly, or you can do that purposefully. And so randomly is if you're very lucky and you put out a survey into the universe on Qualtrics, on MTurk, on Facebook, and anybody in the entire world can fill it out, that's random. But if you're sampling usually children, you're sampling pretty purposefully. If you're sampling schools or you're sampling colleges, you're sampling purposefully and close to home. Okay, so then the descriptive, again, I just want to nail this home. We have to describe the data and understand it before we can infer it with inferential. So 2 different types of statistics, you report both, but you always have to start with descriptive. And the statistics infer the parameters, so what you can use. So your statistics, understanding them can tell you what test to use. Okay, something that you guys probably have heard 100 times, but I think it's really important that we talk about it and that you have it in your documents today. An independent variable, or an IV, is that variable that we manipulate. It's that predictor, whereas the dependent variable is the variable affected by the manipulation. It's the outcome. It is dependent on the other variable. It is dependent. So how does the IV, the independent variable, affect the dependent variable? Or how does pizza affect my mood? Personally, pizza makes me very happy. I love pizza. I have it all the time. So that IV is pizza. How does the DV? It affects my mood. It makes me happy. So then you think about those are your variables. And then the relationship is pizza affecting my mood. Does pizza then the cause of my happiness, or is it something that it's the cheese or something? So it's pulling apart those different things within that hypothesis. The significance. Okay, something really important for you all. So this is the standard we set when we mean a small probability and a hypothesis testing. So you have a theory. I believe that pizza makes me happy. I believe that pizza makes most people happy. So I test all of you guys today, and it is significant within our sample here that everyone has said pizza makes them happier. That is, we then get a p-value you might have heard of a p-value of 0.01 or 0.05. That p-value lets us know that in our sample, my hypothesis was correct, that pizza makes all of us happy. Now we're a sample of only 8 today, so that's not maybe most generalizable to the population, but maybe it's generalizable to graduate students or to Oakland University graduate students. But it's that small probability that pizza making us happy is correct. My hypothesis is correct. So the p-value is that probability of obtaining a test statistic as extreme as the observed value. The p-value is not an indicator of size or importance of an effect. Let me repeat that. P-value, not an indicator. A p-value of 0.01 does not tell you that pizza is incredibly, I'm trying to think pizza is not the most important thing to all of us. Pizza is not we don't all love pizza the same. It's not that at all. It's just that within our group, it was significant that more than chance, we all love pizza. So more than chance, we all love pizza. But it doesn't mean anything different. It just means that p-value is significant. So, for example, pizza. So we hypothesize that Michiganders more than Americans love pizza. So Michiganders love pizza more than Americans. We get that p-value of 0.0058. So that p-value is less than 0.05 and less than 0.01. So it is highly significant because it's less than 0.01. So we affirm our hypothesis. Michiganders do eat more pizza than other Americans on average. But we get that pizza example too. Our hypothesis is the same. Michiganders love pizza more than Americans. We get a p-value of 0.058. Michiganders eat the same or less pizza than other Americans on average. It does not tell us if they eat the same or less. So it has to be much more generalized. It just tells us that Michiganders do not eat more pizza than other Americans. So that leads us to SPSS. So if anyone could put next to their name, raise your hands if you have used the Oakland University of Porto SPSS. Anybody? Okay, well, I'm going to open it up here today in case you didn't get to. So Porto, it actually takes over. Awesome, thanks, Fred. So it takes over your computer. So I won't, but you launch it right here. And SPSS looks like this. It has a similar feel to Excel. So I have it already downloaded on my computer. It has a similar feel to Excel. You've got columns, you've got rows. You have data view, and then you can go to your variable view. So I am going to open data, if it lets me. And I'm going to open the data that I gave you all today in the email. And again, if you didn't get that email from Lily and I, put your email in the chat and I will make sure it gets forwarded to you. Awesome, that is empty. I will open something else. If I can't open that, okay. Then I will open some of my own data, hopefully. Okay, I actually had something saved, luckily. Okay, so you're only seeing the slide. Katie, thank you for letting me know. Okay. New share. Okay, can you see it now? Okay, so I clicked Oakland University of Porto. You would launch it right here. It would come up and it would take over your screen. I have it downloaded on my computer. You have to pay for it, but I can't run a PowerPoint and do SPSS. And I also use SPSS weekly, so totally different. So this is some of my very old data. For those of you who don't know, I work with big cats. So that's why you're going to see some things that are a little bit different, like species, sex versus gender, things like that. So it looks a bit like Excel. You've got all of your columns. I opened my data here. So this is where it looks like Excel. This may be confusing for a couple people. Chapter 1 in the SPSS books tells you how to put your data into Excel. If you're not following with this, again, this recording is made available to everyone. You can put a new data set in. You can put in any type of data, an SAV file, which is SPSS, an Excel file, which is what I was trying to open that wasn't working. So each row here is an individual. So these are all different names of animals that I've worked with. So each row is an individual. Each column is something I measured them on. So these are all time. So time to success. And then you've got different variables here, the number of solutions, the species they were, 1 or 2, the sex they were, 1 or 2. So then we go to variable view. So we have how you define each column. So column 1 is subject, column 2 is success. Column 1 is subject. That's what I named it, but you can change it to name, you can change it to cat, whatever you want. The measure, this is exactly what we talked about and why it's important. SPSS will not let you run tests if you mislabeled your value. So if you put ordinal and it's nominal because it's a name, the number doesn't mean anything. It doesn't even have a number, it's letters, then it won't let you run it. Success is time, so it is scale. So scale represents both ratio and interval. So it's scale. And then we go down to species. So species is nominal because I have 1 ranked as African lions, doesn't mean anything in particular. 2 is ranked as snow leopards. So 1 and 2 have no difference here in their numbers other than they represent for me the species. Same thing with male and female. I put 1 to represent male, 2 to represent female. If you are working with humans, you can put in anything you want. You can add, you can delete. That's what that means. And that is nominal. How to do this and a reminder on how to do this is all in the manual. And I go through every single individual column. I don't want to do that today. I'm just trying to give an overview, but that is how you do that. And I actually go on page 8 and 9 to talk about how you put in data as well too. And I gave you a data set to play around with that the guide goes through. So if you are running tests with it, it does tell you if you are doing it wrong, and the guide tries to make sure you're matching it. Okay, so then your output, which is the other tab for SPSS, shows you everything on the side that you have done when you go to analyze and doing a report. So what I mean about a report, so our descriptive statistics, I want to figure out how many species and of what sex of individual. So I want the mean, that standard deviation, that range. These are those other things that I was discussing. So I run that and it told me I had 15 individuals that ranged from 1 to 2 in sex, which made sense because I have a couple females and a couple males. So it's something in between. Same thing, I had 15 species or 15 individuals, so that N. So if you wanted the frequencies, the same thing, then you would, again, pick the same. And the frequencies gives you something a little bit different than the descriptives. So it's actually kind of annoying. You want descriptive statistics, but always click frequencies because descriptives gives you what you asked for. So that mean, that range, that standard deviation, but the frequencies breaks it down more. So it gives you for African lions, this was the frequency, this was the percentage. For sex, this was the number of males, which represented 60%, excuse me, out of the 15 individuals. And then you can come in here and let's say you're working with multiple populations and you can say, well, these were my lions, whereas these were my leopards, and you can rename everything or use for page 1, and you can rename anything you want and tabulate these over here and hide those away. So you can hide things as you go if you don't want to look at them. So I highly recommend playing around with this and a little bit of the data. Okay, so now let's head back to the PowerPoint. Okay, so it's super important to run descriptives to understand your data. We need to know, and you will have to report with your dissertation or your thesis, how many males, how many females out of the total and your percentages. You also should use it to understand your data. So a ton of questions that you guys will get if you decide to present your research will actually come from your descriptives. So you might report males and females, but you might get a question when you present and say, well, how many of those females were actually from Michigan and how many of those females were from Ohio? And maybe that is something to consider, where in actuality, all of your females from Michigan rated themselves as they don't like pizza. And it's actually the females from Ohio that like pizza. And that's why all your tests were significant, because those females from Ohio, 100% of them liked pizza, whereas the females from Michigan did not. So compared to the males, maybe females liked pizza more. But if you look in your data, it was actually the Ohio females. So it's really important to do as much of the descriptives and frequencies as possible just for yourself. So you need to report those means and standard deviations of sex, where individuals are from, your ethnicity or race, and I'm trying to think of what else, depending on what you're looking at. It could be political party is something to report. It could be the state they live in. It could be the county. It just depends. So it also presents your data in a meaningful and easily interpretable way for your readers. So whether you're presenting at a conference or for a paper, giving that basic information is so important for your readers to understand. If they can understand that your sample is 50-50, it's a great sample, then they will better accept and interpret your results. So if you're telling them that Michigan population loves pizza and your sample is 50 men and 50 women, then I'm going to believe that Michigans love pizza because your results are significant. But if you tell me that Michiganders love pizza and your sample is 75 men and 25 women, and you're telling me all Michiganders love pizza, well, I'm not going to believe that as much because you only had 25 women and only half of those actually said that they love pizza. So maybe it's that male Michiganders love pizza. So it definitely can help you, and it can help your readers and your anybody listening to your presentation. Okay, so that SPSS manual, if you got a chance to look at it, it has a table of contents in the beginning. It gives you how to log in, how to open data, how to upload data, how to write in data. And then that chapter 2 is kind of what I've been talking about, that frequencies and descriptives. That's all of the descriptive statistics is in chapter 2. That's how you do that. And I suggest using frequencies. Your advisor might tell you descriptives, but frequencies for me gives me more information. And I'd highly recommend that for you guys. And then chapters 3 all the way through 8 are those inferential statistics. And that's only a brief piece of how to do inferential. So that gives you the basic correlation, regression, how to understand output, a little bit on non-parametrics, a little bit on ANOVAs, just like a touch on what your most prominent tests that you would have to use, the most popular ones you would have to use. Your advisors might ask you to do something a little bit more complicated, and statistics goes on forever, but this manual gives you the most popular and what you guys would likely use. Chapter 9 teaches you how to make a graph. It's in Chart Builder. Graphs are great. However, for Oakland University and for publications, they do not accept SPSS graphs. So it's great to do. I teach you how to do it in the guide. However, I would not recommend spending time on that chapter. You actually can make them in Excel, and that's how you can get them accepted. And also it's a lot easier because you can save them in Excel and edit them more easily than doing that in SPSS. Then at the end of the manual, I talk about statistics and power analysis and references and acknowledgements. There are other sources to use there, things that I recommend. And each chapter has photos that I hope you guys find helpful with arrows and everything. And feel free to go over that and share that manual as much as you want. I have a printout copy. I highly recommend printing it out, putting it in a binder, and that way you don't have to switch back and forth in tabs when you're trying to work SPSS. Okay, so again, you need to report descriptives, percentages, means, standard deviations, counts. And then for inferential, you report, that's your correlation. So you need to report like those p-values, that what that correlation value is. It's usually an R, what that letter is, your t-test and all of that stuff. And you cannot use SPS tables, SPS. So right here, you cannot use SPS tables or SPS figures for your reporting. So this is really important. So how do you report? How do you need to report? If you have 3 numbers or fewer, you describe it in text. If you have 3 numbers to report in a paragraph, make it a table or a graph. So what I mean by that. So you get this output table from SPSS. Great, it gives me all of the frequencies that I asked for. This many full-time students, this many part-time students, males, females, everything. This has a ton of numbers on there that I find important. So I could report it in text this way, or I could report it in a table. Generally, because it's so much information and I want to make sure my readers have the most information as possible, I personally would report this in a table because you can see how many numbers we cut. So your reader has to assume here that the other part is 7.8%, whereas over here you can see that combination of 7.8 from that 92 straight and heterosexual. Just under half students reported having a spouse or domestic partner, that 43.8. So your reader has to assume that the other half did not. Okay, whereas if you have something like this, it's not that much information. It's that high school average achievement, high school membership. I could report this, and you should report both. You need to report both, but I usually would just report it in text. You should report both for your descriptives and your mean and your range, or you can do your standard deviation here, which that you can see here. You should report both, but here you can see how important it is to report that in a table. I highly recommend using layered for reporting test statistics for different tests. So like I was saying, a Pearson's. So I did a Pearson's correlation. I type in layered what I want to do. I do layered statistics, Pearson correlation. It tells me why I would use Pearson. It tells me my assumptions. It tells me how I would use it. So I click analyze, click correlate, and then it tells me how to read the output. So please use layered if you do not use the manual, or if you want to use a test that's not in the manual, it'll teach you how to do everything and how to read it. And then down here in this general gray box, layered teach you how to write something in APA format. So it tells you a correlation was run to determine the relationship R equals, and it tells you where to find all of those numbers in the table. So the guide does that, but layered does that, I would say, even better. So ideas for improving research: focus on finding the truth rather than supporting your hypothesis. Ethical research is number 1. I know everyone is passionate here about their topic, but you're not going to get anywhere in life if you don't find the truth just to support your research. We are seeing now more than ever that researchers are coming under fire for over generalizing their information or trying to reach or make up numbers. Please don't do that. Focus on finding the truth. So increasing sample sizes. If you work with, like I was saying, us 8 individuals or us 7 individuals, and you want to make a generalization that graduate students love pizza, that's great, but we are such a small sample that it would be best if you asked all of the Oakland University graduate students, and it would be even better if you asked all graduate students within America, and then the next step would be even better to ask all graduate students in the world. Try and make your sample size as big as possible for your research. It's better for your results for statistics, and also better for your generalizability. So avoid piecemeal publication whenever possible. Do not try to cut up one study into multiple different publications. People can see right through that. Nobody wants to see you stretching one publication to create this impression that you have a ton of research and have all of these conclusions when it really only found one or two things that you could have put in research together. You should not try and publish more than 2 publications per chapter of your dissertation. So if by chapter, I mean, if you only do one survey that is looking at one hypothesis, then you shouldn't be trying to publish multiple things from one hypothesis. However, if you're doing a survey that's 100 questions and they're all different questions, then maybe you can get 2 or 3 out of it. So also it's something to think about before you start doing your research is how many publications you want out of it. Okay. Open science practices are helpful. So giving a journal your survey before you actually send it out. They actually then agree to publish your results before you do that. It actually will help you publish something, and it'll also help you get a ton of feedback from editors and things on what you guys should do and should look for. And then again, I just highlight honesty, transparency, humility. We all make mistakes. No research is perfect, but be flexible. Try to understand your research for what it is, not for what you want it to be, and have humility. We all make mistakes and we all could do better research. And your long-term reputation is much more important than this one publication from this month or just trying to graduate. You can just try and graduate with anything you want, but that doesn't mean it'll help you get a job and do research long-term. And don't overestimate your results. And on that note, be careful overestimating your relationships. These are some of my favorite things to show. There is this whole website, spurious correlations. So yeah, per capita cheese consumption highly correlates, is highly significant to the number of people who died by becoming tangled in their bed sheets. Look at that correlation. Oh my gosh, it's so significant. Number of people who drowned by falling into a pool highly correlates with films Nicolas Cage appeared in. Look at these curves are the same. However, those don't mean that they're related. So definitely don't overestimate your relationship. It likely is due to something else. So take a step back and try and think about something before you write that you have found a cure for a number of people who become tangled in their bed sheets. You just reduced cheese consumption. There's likely another reason. Correlation is not causation. So this cat, like that spot, but I would say he didn't cause a roof to collapse. And with that, I'll take questions. And as you can see later on, there is some information on missing data and outliers and what to look for there. But give me some questions. I know it was a ton of information. I tried to get through as much as possible, given our limited, 50 minutes, 45 minutes. So. Okay, I will try to stop recording.
Tori, I have a question. It was what I was